The fourth three-dimensional problem we're going to do deals with bearing. Okay, so Jane stands at a point A in front of a church and observes that the angle of elevation of the top of the spire is 60 degrees. Okay, so if we look at our little picture here, Jane is standing at a point A. She's looking at the church, and the top of the spire, S, that point over there is S. That angle of elevation there is going to be 60 degrees. Okay, now the bearing of the church from the observation point is 345. She walks 5 meters due east and now finds the bearing of the church to be 315. Now, all these angles become really complicated. So it's much better to always first work out everything to do with bearing. And once you've done that, worry about the angles of elevation and depression. So all I'm looking at now is the information that's been given to us in terms of bearing. Okay, the observation point, this is where she is. The bearing of the church from the observation point is 345 degrees. Now remember, bearing is measured from that north-south line. Okay, so if we have a bearing of 345 degrees, we are saying that that angle there is 345. Right? She walks 5 meters due east and now finds the bearing of the church. I've called C. C is where the church is. Okay. This bearing is going to be 315 degrees. So now I have read all the information given to us in terms of bearing, and we somehow have to translate that into stuff that's inside the triangle, something that is of use to us, because that's pretty useless as it is. I'm only interested in angles that lie within triangle ABC. All right, so the first thing we're going to look at is, let's have a look at this one over here. If this angle is 315, okay, then it must mean that this little piece over here is 45, okay? Just short of a complete revolution. This angle from north to west, that angle there is 90. So this angle inside my triangle is 45 degrees. Okay, if I take the little bit over there, 360 minus 345, okay, that's going to give me that this little piece inside there, from my north line to that angle, is going to be 15 degrees. This piece of the angle is going to be 90. So if I take 15 and I add 90 degrees to it, this entire angle here is going to be 105 degrees. So 105 degrees plus 45, subtract that from 180 degrees, the three angles of a triangle, I know that this angle over here must be 30. And now I'm going to not worry about trying to draw my bearing properly. Now I'm going to just say, okay, go back to our three-dimensional shape. Okay, there is the church. That's C over there. Okay, that is S, the top of the spire. All right, this angle over here is going to be 30. This angle is going to be 105. And that angle over there is going to be 45. Right? ACB is 30. CAB is 105 and CBA is 45. And this length from A to B is going to be 5 units. Now that I've transferred all the information about the bearing onto my horizontal plane, let's just shade this. Okay, I've transferred everything to my horizontal plane. Now I can listen to, what it says about the angle of elevation. The angle of elevation of the top of the spire is 60 degrees. From A, I look towards the church. I'm looking along that horizontal line. That angle there is 90. The angle through which I look up at the top of the spire is going to be 60 degrees. So this angle over here is going to be 60 degrees. Now we're trying to find the length of SC. Okay, so again we have to do our plan. Ultimately, I want to find SC, and if I want to find SC, I'm going to have to work in SCA. Before I can work in that triangle, I need to work out AC by working in triangle ACB. So that's my plan of action. We start off by saying in triangle ACB, I have a side and its opposite angle. I have that pair that allows me to use my sine rule. So I'm going to say AC over sine of 45 is equal to 5 over sine of 30. AC over sine of 45 is equal to 5 over sine of 30. A little bit of algebra allows me to say that AC is equal to 5 times sine of 45 all over sine of 30. Now I'm going to do this one without using my calculator because these are special angles. Okay, so it is possible for them to say do a sum without using your calculator. Sine of 45 becomes root 2 over 2. Sine of 30 is a half. To divide by a half, I'm going to tip and times, and so I land up with 5 root 2 divided by 2 times by 2. I have finished the first part of my sum, and now I want to work in triangle SCA. Triangle SCA is a right angle triangle. I know my adjacent. I want to work out my opposite. So I'm going to say that tan of 60 degrees is SC, the thing I'm looking for, over AC. Algebra step, AC times by tan of 60 is equal to SC, and I'm going to substitute in the value I've already worked out for AC. So I can say that SC is equal to 5 times root 2 multiplied by tan of 60. Again, that is a special angle, and tan of 60 happens to be root 3. So we could get that answer as 5 times the square root of 6.